right. We're talking about the sum and difference of two cubes today. Sum and difference of two cubes. Okay. So, say I had the sum of two cubes like that, right? I had a perfect cube and I was adding to another perfect cube. You can factor this using this pattern. A plus B. So your first factor will be the cube root of each one. The other one will be a squared minus ab plus b squared. So, dare I try again? Yes, I dare, because I want to make sure that we're right. Miss Saber, you mean to tell me if you multiply these two things together, you're going to get that? Well, let's see. A cubed minus a squared b plus ab squared, and now b times all that, plus a squared b minus ab squared plus b cubed. Combine our like terms. Let's see what happens. I got a minus a squared b and a plus a squared b, so they're gone. A plus ab squared and a minus ab squared. Oh my goodness! Check that out. I have a cubed plus b cubed. Yeah. So let's watch how to use this. If I look at my worksheet here, 5 is the difference, so let's actually do 6 first because that one's a sum. Yeah. Sure, after. So I'm just going to recopy number 6 here as x cubed plus 1. All right, so if I want to factor this, I'm just going to follow the same pattern. So a is really the cube root of this, and b is the cube root of that. So what's the cube root of x cubed? Just x. And what's the cube root of 1? Just 1, right? So that's really a, and that's what goes in for b. So when I follow this pattern, a plus b, it's really what will go in this first thing here? A, which is really x plus 1, right? It's the cube root of each one. So the cube root of that and the cube root of that. Now, in my trinomial here, I need whatever a is squared. So what would that be? X squared. And now I want to minus the product of a times b. So x times 1 is just x, so I would minus x. And then add b squared. 1 squared is just 1. So there is the sum of two perfect cubes factored. Let's try one more example. Let's say you had something like, well, what if you had like a 8x cubed, plus, plus 27. So, is this first chunk a perfect cube? Yeah, right? Because 8's a perfect cube and so is x cubed. And 27, that's a perfect cube also, right? 3. So, what is the cube root of 8x cubed? 2x. So that, guys, is what I put in place of a. What's the cube root of 27? 3. So that is what I put in place of b. Does that make sense? And now I'm just going to follow the pattern. So let's see if I can get the pattern up here at the same time. So go ahead. What would this first thing be? 2x plus 3. 2x plus 3. And then it would be, careful here now. Yes, because a is 2x, so I'd have to square the whole thing. So it'd be 4x squared minus the product of the two. Yeah, so minus 6x and then plus b squared. Plus 9. Perfect. Does that make sense?
So is that just your answer then?
Well, that's it in factored form. We're going to go one step further and then solve it, but we need to know how to factor it first. So let me give you one to try without me telling you what to do. Try, how about let's do x cubed plus 1,000.
Now that's easy. Tricks of
So just factor this one following the pattern. Let's see if I can get them both up here at once. I like to figure out what A is and what B is, and then I just follow the pattern.
There's the method.
Yeah. Okay, did you get it? So what's my first binomial?
X plus 10.
X plus 10. And then the next one, my trinomial would be? X squared
Minus 10x
minus 10x
plus 100.
plus 100. Perfect. Great job. So if you can take the cube root of each and you know the pattern, you should be all right. Now, the difference of two cubes is almost the exact same pattern. There's just a tiny little change that you need to make. So, let's see, where should I stick this? I'll put it here, but I'll do it in a different color. How about, let me grab this green. So if you had the difference of two cubes, so say you had a cubed minus b cubed, instead of having a plus b, now it's a minus b. And then this is weird because all of these are pluses. It's the same ones. It's a squared plus ab plus b squared. So it's all the same pieces. It's just one tiny movement of the negative. So that one starts a plus b and it has the negative in the middle. This one has the negative in its binomial, and its trinomial are all pluses. So if you have the difference of two cubes, you just follow this pattern instead. Okay, so you just have the negative there and all positives here. So let's try number 8, for example. 8 is just y equals x cubed minus 27. So again, I like to figure out what a is. What would a be? Just x, right? So that's a. And then what is the cube root of 27? Don't worry about, yeah, it's just 3. The minus just tells me which formula to use. So 3 is going to go in for b. And then I just pop in the formula a and b as they are. So I would get, let's see if I can squeeze this in here. A minus b, so it'd be x minus 3, and then a squared plus a times b, so it'd be a plus 3x, and then plus b squared. That's it. Does that make sense? Okay, so if we are looking at this worksheet here, we want to go one step further and we want to solve it. So let's just take what we just did for number 8, and we factored it, and we got x minus 3 and x squared plus 3x plus 9. Okay, well, if I need to solve this thing, what do I do? Once it's factored, what do you do? Yeah, I set h factor equal to 0. One of my answers is just 3. That's easy. This thing is where it's going to throw some trouble, right? You can try and factor it again, but they don't factor again. So there are no factors of 9 that have to be 3. So what do? Well, I have one of my answers already. It's 3. Now, guys, isn't this a quadratic? Don't I have 4 ways to solve a quadratic? Yeah. So I'm going to have x squared plus 3x plus 9. I set it equal to 0. Factoring doesn't work. We already figured that out. I can't solve by square rooting. I'm going to have to do completing the square or quad formula.
What?
I would agree, because that's odd. So, throw this into quad formula, and let's see if we all end up in the same place. Did you guys get what I got? This crazy thing? Did you? Or no? Did anybody get this? You did? Okay. So, how many answers am I supposed to have? 3. How many are right here? 2, right? It's negative 3 plus that divided by 2 and negative 3 minus that. So don't forget your other one. Remember I had a 3 from way back there. So it'd be that and 3. And there's my 3 answers on my answer line. Does that make sense? So as long as I have the sum or difference of 2 cubes, I can find all the roots using that pattern. So why don't you guys try number 9 maybe without me telling you what to do. So find me the 3 solutions to that thing. So first you're going to factor it using our pattern and then set each factor equal to 0 and solve. Oh. Come on, Miss Abia. I do.
Dang it.
Sure. Philip, did you have a dismissal form that you may have forgotten to turn in?
Stupid idiot.
Oh, a no? You do have it?
Yeah.
Yes, he does. Yes. No problem. Bye. So they want that note now, so I guess you might as well go.
I'll do that. Yeah? I'll set her mail at like
Did everybody find 3 answers? So let's find these 3 together. So I notice, oh, I have difference of 2 cubes. You still should be checking if there's a common factor to factor out. I just don't have any here, so I can't do that, but I do have difference of 2 cubes. So I take a look at the first term. The cube root of that would be what? 3x. So that's what goes in place of A. And the cube root of 1 is just 1, so that's what goes in for B. And then I'm just going to follow the pattern for difference of 2 cubes. So that's going to be 3x minus 1, and then all of these are pluses. So it's a squared. So make sure you have 9x squared, not 3x squared. You got to square the whole thing. 9x squared plus a times b would just be 3x, plus b squared is just 1. So that's how you should have it factored to start off with. And then I'm just going to set each one equal to 0 and solve. So from that one, I get a positive 1/3, right? So that's in my answer key, positive 1/3. And then from this, I don't know what the heck I'm going to get, but there's going to be 2 of them, right? 2 things are going to come from this quadratic. So I'll try and factor, but there are no factors of this that have to be that, so I can't do that. I'm certainly not going to try completing the square on this. It would be a nightmare, so I'll just quad formula. Negative b plus or minus square root b squared minus 4 times a times c all over 2a would be 18. So that's going to get me, that's a negative 36, so it's negative 27 again. Right? So I already did that. That was a negative 3i root 3. And it's all over 18. It can be simplified, and it should be. So remember, if all 3 numbers out in front here have a common factor, you gotta divide by that common factor. And I can. So let's divide them all by 3. So it'll be a negative 1 plus minus I root 3 all over 6. Looks good to me. What do you think? So really, the only new piece here is these 2 patterns, right? Knowing your sum and difference of 2 cubes. And then, because once you have them, then it's just setting them equal to 0 and solving from there. So when we come back from lunch, we'll talk a little bit about the backside, which is a little bit different, but it's not anything you don't already know. All right, so we will stop here.